Welcome to Lesson 4 of Module 3 on the Relational Data Model. I'm going to start with a practical question that I want you to think about during this lesson. Why are constraint names important? Imagine that you are on call as a database administrator. An error occurs, but the error name is meaningless. Lesson 4 continues your learning about the create table statement. In this lesson, you will extend your knowledge and usage of the create table statement to integrity constraints. Practice and graded problems will be based directly on the details of this lesson. The objectives of this lesson involve extended details of the create table statement. You should be able to read and write create table statements containing primary key, foreign key, unique, and check constraints. Before presenting examples of constraints in the create table statement, let's begin with a brief overview of the subject and placement of constraints. After this overview, I will show a number of examples that you can mimic in the practice and graded problems of this module. The create table statement allows 5 different subjects in constraints: primary key, foreign key, unique, required, and check. Unique constraints indicate that a column or combination of columns has unique, that is, non-duplicate values for a table. Unique constraints are not specified for primary keys, as the primary key constraint already implies uniqueness. Unique constraints are specified for candidate keys. These are other columns besides the primary key that are also unique in a table. For example, a student table may have STD number as the primary key and STD email as the candidate key specified with a unique constraint. Required constraints using the not null keywords indicate that a value must be entered for a column with null values not allowed. Check constraints specify conditions that a column must satisfy, such as limits on a column containing a year value. Constraints may be placed inline as part of a column definition or external after column definitions. Constraints involving more than one column must be placed external to column definitions, as you will see. Let's begin with examples that isolate just the constraint part of the statement. Later parts of this lesson will put the constraints into complete create table statements to show their placement. The first 2 examples depict primary key constraints. The second example must be placed externally because the primary key is a combination of 2 columns, offer number and STD number. The third example is a unique constraint with the unique keyword. The fourth example defines a foreign key constraint with the foreign key column, that is offer number, and parent table offering specified in the constraint. The last example defines a required constraint with the not null keywords. Required constraints are usually specified in line as they apply to individual columns, not combination of columns. Each example begins with the constraint keyword followed by a constraint name. The constraint name is optional, but good practice to identify the error when a constraint violation occurs. The keyword constraint is optional for inline constraints, but required for external constraints. This create table statement for the course table shows 2 external constraints. The constraint named PK course defines a primary key constraint. The constraint named unique CRS description defines a unique constraint for the CRS description column. Both constraints could be placed in line because they involve a single column. This constraint statement for the enrollment table shows 3 external constraints. The constraint named PK enrollment defines a primary key constraint for the combination of offer number and STD number. This constraint must be external as it involves multiple columns. The other external constraints involve foreign keys. These constraints can be inline or external because they involve only single columns. The create table statement for the offering table shows 3 inline constraints and 3 external constraints. Required constraints with the not null keywords are typically placed inline because they always involve individual columns. The constraint keyword and constraint name are optional for inline constraints. Inline constraints are written after the data type specification. The comma is necessary after the inline constraint to terminate the column definition. The three external constraints are similar to external constraints in other examples that you've seen. Check constraints with the check keyword define conditions that columns must satisfy. Conditions typically involve a column name, a relational operator such as greater than, and a constant or another column name. If more than one column name appears in a check constraint, all columns must be from the table defined in the create table statement. These examples depict 4 check constraints. The first 3 check constraints can be placed inline or external. The 4th check constraint must be placed external because it involves multiple columns. Each check constraint contains the constraint keyword, constraint name, and condition inside of the parentheses. The first check constraint involves a between operator, indicating that the std_gpa column must be between the values 0 and 4 inclusive. The second example uses the in operator, indicating that the student class column must be one of the 4 specified values. The last constraint shows a condition involving 2 columns. Both columns must come from the table defined in the create table statement. SQL compilers will not permit check constraints that involve columns from a table different than the table defined by the create table statement. Let's wrap up this lesson that provided examples of constraint specification in the create table statement. The examples in this lesson demonstrated primary key, foreign key, unique, required, and check constraints. Most examples were shown for external constraint placement. Required constraint examples were placed inline in the examples, as typically occurs in practice. It is good practice to use constraint names to facilitate problem solving when a constraint violation occurs. A DBA on call will be helped at least initially by seeing a meaningful constraint name when a violation occurs, such as a non-unique primary key value. You should also note the limitations of check constraints. Only columns from the table in the create table statement can be used in a check constraint. If you are using MySQL for the practice problems and graded problems, you should study the document on the course website containing MySQL create table statements. MySQL does not permit the constraint keyword and constraint names for required and check constraints. Oracle, however, does not have these restrictions.